Right now, an earthquake swarm is battering Granada, Spain. 4 significant earthquakes and more than 500 smaller events have struck this region since August 14, 2026, and there is already visible damage to buildings, cracked walls, fallen BX structures, now sitting at reduced structural integrity before anything bigger has even happened. This is not a minor local story. This is happening in one of the most seismically dangerous locations on the entire Iberian Peninsula. And the reason it deserves your full attention is not just what has already struck, but what this specific location is capable of producing. Let's start with where this is happening and why that location matters so much. The Granada Basin sits almost directly above one of the most unusual and violent tectonic settings in Europe, the Gibraltar subduction arc. Beneath the Strait of Gibraltar, a remnant slab of ancient Atlantic oceany. Sea crust is being forced down beneath the Iberian Peninsula, diving almost vertically into the mantle. This subduction has produced some of the deepest, most powerful earthquakes ever recorded in this part of the world. In 1954, AAMA, magnitude 7.8 earthquake struck this exact region at a depth of roughly 630 kilometers, one of the deepest and largest deep focus earthquakes on record anywhere on Earth. Because it occurred so far underground, its destructive impact at the surface was limited, but its size was almost unimaginable. A magnitude 6.3 struck at a similarly extreme depth, greater than 600 kilometers down in 2010, confirming this is not a one-time anomaly. The slab is still down there, still sinking, still capable of producing enormous deep earthquakes on a recurring basis. Directly above that sinking, cold, dense slab, geophysicists have measured a significant gravity anomaly centered almost exactly where the Granada Basin sits. That is not coincidence. Dense subducted material pulling downward at depice. The key is one of the forces believed to have shaped and continues to influence the extensional basin at the surface, the very basin now producing this swarm. Deep tectonic processes and shallow surface faulting in this region are mechanically linked, even though they happen at wildly different depths and by different mechanisms. And that surface layer has its own violent history entirely separate from the deep subduction earthquakes. The most devastating example is the 1884 Andalusia earthquake, estimated at magnitude 6.6 to 7.0, with a hypocenter only about 8 kilometers underground, shallow, close to the surface, and catastrophically destructive as a result. That earthquake killed an estimated 839 people, injured roughly 1,500 more, destroyed more than 4,000 buildings outright, and damaged over 13,000 additional structures. In some villages, 90% of buildings were leveled completely, and the remaining 10% were left so structurally compromised they were unlivable. 3 separate international commissions, formed by Spain, France, and Italy, studied that earthquake in detail, and their findings still shape how seismologists understand this basin today. It occurred on a steeply dipping normal fault, the same type of fault mechanism seismologists are seeing in the current swarm. That history is exactly why the current swarm has drawn so much serious attention. This is being described as the strongest earthquake swarm to hit this region in decades, potentially the most significant since that 1884 event, when accounting for cumulative energy release. To understand how serious that framing is, you need to understand what has actually happened over the past several days. 4 major earthquakes have struck since August 14th, according to the USGS, a magnitude 5.2, followed by a cluster of 3 more events, a 4.9, a 4.6, and a 4.7, all within roughly a 2-hour window. Spain's own seismic monitoring agency, the National Geographic Institute, known as the IGN, has recorded these same events at consistently lower magnitudes, 4.8 for the first quake instead of 5.2, and lower readings across the board for the later events as well. When you calculate the cumulative magnitude, the discrepancy becomes significant. Using USGS numbers, the cumulative magnitude across these 4 events comes out to approximately 5.35. Using IGN numbers, it comes out to approximately 5.03. That difference sounds small on the surface, but because the earthquake magnitude scale is logarithmic, that gap actually represents roughly 3 times more energy release according to USGS calculations compared to IGN's somewhere between. And those 2 numbers sits the truth, and honestly, no one outside the seismic agencies knows exactly where. What is not in dispute, regardless of which agency's numbers you use, is that a cumulative magnitude 5 sequence has now struck this basin in a matter of days. And more than 500 total earthquakes have been recorded since the swarm began, including at least 9 events of magnitude 3 or greater and 45 strong enough to be felt directly by the population on the ground. According to IGN's own published report, these earthquakes are concentrated in a shallow band near the towns just south of the city of Granada, almost all occurring at depths shallower than 10 kilometers. Shallow earthquakes, even at moderate magnitudes, tend to produce disproportionately strong shaking at the surf. Haste precisely because there is so little rock between the rupture and the people standing above it. That is a critical detail, because it is exactly what residents in this region are describing right now. Shaking that has lasted far longer than a typical moderate earthquake. Cracked walls, fallen objects inside homes, and a population that is, understandably, on edge every time the ground moves again. Now here's the part that should make everyone pay closer attention. This swarm is not occurring on a random patch of ground. It is occurring in a basin laced with multiple active fault systems, several of which are individually capable of producing earthquakes well beyond what has struck so far. Recent research into the fault systems running through the Granada Basin has calculated maximum potential magnitudes ranging from roughly 6.3 up to 6.9 for individual faults in this basin alone, with fault lengths ranging from roughly 15 to 23 kilometers. In the neighboring Guadix-Baza Basin, calculated maximum magnitudes reach as high as magnitude 7.0 on faults up to 37 kilometers long. The general rule in earthquake science is straightforward. The longer a fault, the larger the potential rupture and the larger the potential earthquake. This basin has no shortage of faults long enough to produce a genuinely major, destructive event. This is not a theoretical concern layered on top of an otherwise quiet swarm. Loading of nearby faults by a large earthquake is a documented, physically understood process, and this basin has direct historical precedent for it. Following that, Minyazinho Saiv 1954 deep focus magnitude, 7.8 earthquake. 2 separate magnitude 5 class earthquakes struck within the same basin in the following 2 years. A magnitude 5.1 in 1955, and another magnitude 5 event roughly 3 kilometers away in 1956. Large, deep earthquakes send seismo, icy energy upward through the crust, and that energy can load stress onto shallower faults that are already sitting close to their breaking point. It is not proof that a bigger earthquake is guaranteed to follow the current swarm, but it establishes that this exact mechanism, a big, deep event followed by moderate, shallow earthquakes in the basin above it, has happened before in this exact location within recorded history. The historical catalog for this region goes back even further. A large earthquake in 1431 was estimated to have produced an intensity of 8 to 9 on the Mercalli scale, a range described as severe to violent shaking. Another significant sequence struck the neighboring basin in 1531 with a Baza fault rupture estimated near magnitude 6.0 and an intensity of 8 to 9. These are not isolated anomalies. They are part of a long, recurring pattern of major seismic activity across this basin system, spread out over centuries, but consistently returning to the same structural setting. Swarms themselves are not new to this basin either, which is part of why seismologists take the current pattern seriously rather than dismissing it as an unprecedented anomaly. A swarm in 2020 through 2021, known as the Santa Fe sequence, produced more than 5,000 recorded events over nearly a full year, including 6 earthquakes of magnitude 4.0 or greater, peaking at a magnitude 4.5 in August of 2021. Smaller swarms occurred in 1988, 85, and 1979 as well, each producing hundreds of events at lower peak magnitudes. What makes the current swarm stand out against that backdrop is speed and intensity. It has already produced a cumulative magnitude comparable to, or by some calculations exceeding, that entire year-long 2020-2021 sequence. And it has done so in just 4 days. It's worth being direct about what that means and what it does not mean. A swarm does not guarantee a larger earthquake follows it. Many swarms simply run their course, release accumulated stress in a series of moderate events, and gradually taper off without producing anything larger. That is a completely normal outcome, and it happens regularly in seismically active regions around the world. But it is also true, and well documented in the seismological record, that some swarms are faux reshock sequences, the early signal of a fault building toward a larger rupture, not the full release of stress itself. There is no reliable way, with current science, to know in advance which category a given swarm belongs to while it is still unfolding. What can be said with confidence is the simple presence of an active swarm on faults capable of producing a magnitude 6 or higher event represents an elevated risk compared to normal background conditions. That is not fear-mongering. That is how seismologists in active fault zones describe this kind of situation, because the historical record repeatedly shows swarms preceding larger events in exactly this kind of setting. And there is a very specific reason the structural risk here is higher than the raw magnitude numbers alone would suggest. Ground composition matters enormously in how a given earthquake translates into actual shaking and actual dam age. Seismologists use a measurement called VS30, the average shear wave velocity through the top 30 meters of the ground, to estimate how strongly a given location will shake during an earthquake. Lower VS30 values generally mean softer, looser sediment, which amplifies shaking through a process called resonance amplification. Around Granada, VS30 Values drop into ranges associated with meaningful amplification risk, largely because the basin is filled with sedimentary material rather than solid bedrock. This is the same basic mechanism that made the 2014 South Napa earthquake in California so much more destructive in certain low-lying areas than in others just a short distance away, even though both areas experienced the same underlying earthquake. Soft basin sediment does not just transmit shaking, it can intensify it. This is a documented part of why the 1884 Andalusia earthquake was so catastrophic, despite its moderate to large but not extreme magnitude. The combination of shallow rupture depth and basin resonance turned a magnitude 6.6 to 7.0 event into a death toll in the hundreds and near total destruction in some villages. That history is precisely why the visible building damage already reported from this week's earthquakes is so concerning. Cracked walls and structural stress from a cumulative magnitude 5 sequence are one thing on their own, but those same buildings, already weakened, now HO, have less capacity to withstand any additional shaking. If a magnitude 6 event were to strike on one of the basin's shallow faults in the near term, it would be landing on infrastructure that has already been compromised in a basin and geologically prone to amplifying exactly that kind of shaking. That combination, recent structural damage, plus basin resonance, plus faults capable of producing a magnitude 6 to 7 event, is the core reason this swarm is being treated as a serious, closely monitored situation rather than routine background seismicity. There is also a structural detail from recent research worth understanding, because it explains why this basin behaves the way it does at depth. Beneath the Granada Basin, the network of STEEP surface faults connects to a more horizontal detachment structure, roughly 10 to 12 kilometers down, which deepens further to 20 to 25 kilometers toward the southwest. The crust in this region runs roughly 35 to 38 kilometers thick before transitioning into the upper mantle. In simpler terms, this is a genuinely complex, multi-layered fault system, not a single simple crack in the ground. Complex fault systems like this are exactly the kind of setting where energy can migrate from one fault segment to another during an active sequence, which is part of why the 2020 to 2021 swarm showed activity jumping between different fault segments over the course of the year it was active. Seismic monitoring agencies, have deployed portable seismographs specifically to help map which fault or faults are currently active in this swarm, because in some cases, a fault only becomes clearly identifiable once it actually produces earthquakes. Now let's talk about what happens next, because that is the question everyone watching this situation actually wants answered. And the honest answer requires some care. Nobody can tell you with certainty whether this swarm will taper off over the coming days or escalate into something larger. What can be said is this. Based on the fault lengths mapped in this basin, a shallow crustal earthquake here could reasonably reach into the sites, magnitude 6.5 to 7.0 range, if one of the larger fault segments were to fully rupture. That would be an entirely different category of event from what has struck so far, and given the already documented structural damage in the basin S amplification characteristics, an event of that size would pose a serious threat to buildings across the region, particularly older structures and anything already weakened by the past several days of shaking. This is separate and distinct from Naima and the deep focus subduction earthquakes like the 1954 event. Those can technically reach even larger magnitudes at depths of 600 kilometers or more. But because they occur so far underground, they are felt over an enormous area without the same concentrated destruct. Hive force as a shallow crustal earthquake closer to the surface. A magnitude 6.5 at 5 kilometers deep is a fundamentally more dangerous event for the people living directly above it than a magnitude 7.8 600 kilometers down. For residents in the affected area right now, the practical reality is straightforward and worth stating plainly. Already damaged buildings need to be assessed before anyone assumes they are safe to continue occupying without inspection. Emergency preparedness, knowing evacuation routes, keeping emergency supplies accessible, having a plan for where to go if a stronger earthquake strikes, is a reasonable precaution. In an active swarm on faults, capable of producing a significantly larger event, regardless of whether that larger event actually materializes. Local seismic authorities are continuing to monitor the sequence in real time, deploying instrumentation and updating damage and intensity assessments as more information comes in from the more than 15,000 felt reports submitted by residents through official channels so far. It's also worth being clear-eyed about one more thing. The discrepancy between USGS and IGN magnitude readings, while real and worth noting, does not change the underlying picture. Whether a cumulative magnitude of this sequence is closer to 5.0 or closer to 5.35, the basin is producing its strongest documented swarm in decades on faults, with a demonstrated historical capacity for magnitude 6 to 7 ruptures, in a location where shallow shaking is amplified by soft sediment, with buildings already showing structural damage. Every piece of that picture holds true, regardless of which agency's exact decimal point you use. To put the current moment in its full historical context, this is a region that has produced a magnitude 7.8 deep focus earthquake, a devastating magnitude 6.6 to 7.0 shallow earthquake that killed hundreds of people, multiple magnitude 5 class earthquakes following major deep events, and now the strongest swarm activity documented in this basin in decades, potentially since the 1880s when you weigh cumulative seismic energy. The Gibraltar subduction arc beneath this region is not a dormant curiosity. It is one of the most seismically active zones. NES on the entire Iberian Peninsula, and Spain's own seismic monitoring agency, has formally identified Granada as the highest seismic risk zone in the country. That designation existed before this swarm began. This swarm is simply the latest, and currently the most intense expression of a risk that has been documented and studied for well over a century. So where does this leave things as of right now? The swarm remains active. More than 500 events have struck in just 4 days, ranging from imperceptible microquakes up to the magnitude 4.7 to 5.2 range, depending on which agency's numbers you use. Damage assessments are ongoing, with cracked walls and fallen objects already documented across the epicenter zone. Site and officials say those intensity assessments will continue to be updated as more reports come in. Whether this sequence tapers off over the coming days, continues for weeks or months, the way past swarms in this basin have, or escalates into something significantly larger, remains genuinely uncertain. And anyone telling you the "I know for certain which outcome is coming" is overstating what the science can currently predict. What is certain is that the underlying fault systems beneath Granada are capable of producing an earthquake substantially larger and more destructive than anything that has struck so far this week, that this exact basin has done exactly this before, more than once, across recorded history, and that the current combination of active faulting, basin resonance, and already damaged infrastructure is a genuinely serious situation that deserves continued close monitoring rather than dismissal. This is a live, unfolding situation, and the next several days and weeks will matter. Watch the updated damage assessments from Spain's seismic monitoring agency. Watch whether the swarm continues at its current pace, escalates, or begins to taper. And watch whether any of the region's mapped fault segments, several of which are capable of producing a magnitude 6.5 to 7.0 event, show signs of the kind of accelerating activity that has historically preceded larger earthquakes in this exact basin. This is not a guarantee of what comes next, but it is not a situation to look away from either. This is not looking good, and it deserves to be watched closely until it resolves one way or the other.